part of chapter 1, which is basically we will have talk about the meaning of the object again to make sure that you understand what is the object exactly. And then we can explain some of the properties of the object. We talk about how do we identify objects from each other. We said that each object is self-sufficient entity by its state, its identity, its behavior. Think about the programming way. We will discuss some of the operation that the object can do and what are their types, and also talk about some of the roles and responsibility for each objects in the system. And we'll talk about object and class. We will have to know the difference between them and what are the main relationship or the main concept between them, because they are the core of the object-oriented methods. Now let's start by looking at the meaning of the object again. Again, we talk about the object. What is the object? Okay, we said that everything around you is an object. Okay, and we say that object is something that physical that you can actually look at, you can feel it, you can touch it, and something like that. So it has behavior and it has some properties. And we say that, for example, a table, it has some properties such as the color, such as the number of legs, such as the shape, and some of the operation is what? Moving or upward or forward or something like that. We talk about the car as well. All right. So again, an object is a tangible entity, okay, that exhibit more well-defined what? Behavior, okay? Something that you can see, something that you can touch, and so on, all right? And a formal definition, if you want a formal definition, as a IT, an object is a concept, okay? Is what? Is a concept, abstraction, or thing with sharp boundaries and meaning for application. That means it's something that exists. It could be a logical thing, but most of the time will be something exists, an abstract for something in real life, and it has some boundaries because there's something inside the object, nobody can access it, and through these boundaries, nobody can cross these boundaries, and it's meaningful in the application because the application depends on many objects, and these objects interact with each other. So this is the definition of the object as a general view, as an IT view. Now, again, we will talk about object-oriented programming. Now, each object, okay, each object already exists, already has something that you can feel, you can touch, has three things, okay, that can be identified for the object to be recognized from other objects. Okay, how do you know, for example, Bashir from Abir? They're both students, are they? Yes. How do I know Bashir from Abir? Because they have different ID. Okay, they have different probably major. They took different courses, so they are different. Okay, their names is different. Okay, the place they live are different. Something like that. So we can recognize now object through three things. Okay, each object will have identity, state, and behavior. Okay, identity, state, and behavior. We'll talk about each one, and then now in general, identity means something that identifies the object. For example, the name or the ID could be much better identification for the student. No student has this. No two student there's has the same ID number. Okay, should be different. So this is something called identity. All right, and whenever you go to any government organization or something, they ask you to show the ID. Okay, which is something that identify you exactly. Okay. And also there's a behavior, okay? The behavior is something that you can do. So the student can register courses, can come to the school, come to the class, can withdraw courses, and so on. These are the things that the object can do. What is the state of the object? That means what's the current situation that the object is currently in. For example, a student is having a lecture now. This is a state for the object. Okay, and you can look at the picture that shows the identity. This is the hammer, and this is the behavior that can, hit the nail. And this is the identity where a card is, sorry, a state. A card shows that what is the state of the hammer. Okay. Now the object, probably you would know that you need the object and you model it as you need in the application. It's not just you put an object with identity, state, behavior. These identity and state and behavior will be modeled according to the need in the application. Okay, let's talk about each one separately. All right. Now the object state, we say it is the state of the object. We took an example. For example, the student currently is having a class. So the state of the object is having class. Similar to the traffic light. The traffic light either red or green or blue. Okay. So basically, it is the situation that the object is currently in. So the object can be formed or known by all the properties of the object. Okay, usually will be static. Current value for these properties, which is dynamic. For example, what do you mean by static? So if you say the student object, okay, has a property called name. The name is static for all objects. All students should have a name, but the value for the name could be okay, could be Abir, could be Muayyad, okay, could be any name. So the property is constant, but the value is what? Is dynamic, is change, is different value. All right. Now, okay. Now, the value of the probability changed. Okay, this will represent the behavior of the object which change the value. So when the object do something, the probability will change. Now the probability, if the probability change, that means the state of the probability could change through these things. Okay, so all the probability, for example, a person net worth this amount, for example. Okay, a person net worth may grow up. Okay, so have some value, and the value code what could be dynamic, not just fixed value. The value is static, such as the car serial number. Okay, it's a static one. It cannot be changed. Or the car engine number, or the IB address, or something like that. So if it's fixed, it could be static. If it's changed, we call it dynamic. Okay, the state of the object basically will change based on the event. Okay, so the object interact with each other through a message. We said that. Okay, through a messages. Now the message will happen through an event happening inside this object or inside this object. When the event happens and responds to something, it will change some of the probabilities, and that will affect the state of the object. Maybe will change the state of the object based on what happened, what kind of action happened, what kind of values associated to the probabilities. So this is the state of the object. Take an example as a traffic light, red, green, and blue. Not blue, sorry, green, red, and yellow. Maybe they will add blue in the future, okay? Okay, now, object behavior is more like an action, okay? If something happened to you, you react, you do something, okay? Why do you do something? Because you have to react against something. Same thing happens with the object. If you have object, okay, and this object receive a message or has to do something at point of the time, it will do some functions, it will do some operation, okay, to react to something. That maybe this function or this operation might be happen because the state changed, because some message coming to the object, because a function, another object called the object, okay, So it is kind of, related to each other. Behavior is how an object act and react in terms of its state change and message passing. Now, okay, there's attribute in the object, okay, and the object is already in relationship with other objects, okay, and in other objects, okay. So if the values changed in this object, it could be in order to what? In order to meet the relationship with the other object, okay. So there's a something called behavior bind structure of the object, okay, to their attributes and the relationship to other objects. So the behavior could happen because what? Because to somehow deal or interact with other objects. Okay, now the object operation, we call it what? Behavior. We call it what? As object behavior. So when you hear behavior, that means what? Operation, because the operation represented by behavior. Okay. Now, when you send a message to an object, okay, basically you call a method. All right. So any interaction between objects is a call for a method by sending a message or requesting to change some value or requesting a value or something like that. Okay. Now, any function will be executed after that could change the state of the object. All right. So the behavior of the object is embedded in some of its operation. Okay. So the behavior of object is basically include the object operation. Okay. So we know what's the meaning of the state. In general, the state means what? The current situation that the object is currently in, and also object behavior means the method or the operation that the object can perform. Now, if you perform an object, it could change the state of the object, or if you change some of the probability, it could change the state of the object. And also, don't forget that behavior is already executed because there's a relationship between the between each other in the application, and they need to interact with each other, so they execute method, and that will make change in the object. Now, object behavior, there are three types: simple, state, and continuous. Simple is just, you ask me for something, okay, and I do it for you. It's just a simple request, okay. You ask me for something, okay, and I will pair a function. So I am an object, I will not do anything, okay. If someone asks me a request, okay, then I pair my function. I will do a function or behavior against this object, okay. I will not keep any history, okay. I'll just perform your request, and that's it. I will forget what I have done, okay. No need to keep what happened, okay. This is called simple behavior. State behavior, okay. If something happened, it's not necessarily a request. If some or any value changed inside the object, a function will be executed. So it depends on a condition that happened, okay, distinguishable condition happen, then the object will perform a state behavior, okay, a state behavior that could change the state of the object. This is why we call it a state behavior. Continuous, it is okay. Now you perform an action, okay. The output of this action, okay, will be sent to another behavior or another method, do something. So you perform, okay, and you have an output. If you need to perform a new function now, new function will depend on the output from the previous function. That we call it what? Continuous, okay, which means you execute more than one function, and the input of the current function will depend on the previous function. So this is the object behavior. We have three types of behavior. Simple, I'll do your request and that's it. State, I will do perform a behavior or an operation based on a condition. Continuous, no, it will perform more than one action, and each action will depend on the previous action output. So very simple and easy. The object identity is somehow has to be unique. It is used to distinguish this object from other objects. Okay, so you say this is my car, for example. How do you know this is my car? Because it has a registration number, it has different color, it has a brand, it is registered under my name. So this is the identity of the object. Okay, even if some of the values or all the values are changing over the time, the object identity is still unique and could be recognized in the system. Okay. Now, the object identity, technique used for identifying object. It could be the value of the data inside the object. For example, the primary key inside the table. So I know this is the table I want. The name of the object is basically mainly used to identify the object, such as the file in your folder. What's the name of the file? You cannot have two files in the same name. Okay, it will ask you to, there is duplication. Okay, you have to change the name. So the name could be what? Could be something that you use to identify the object. And there's something called built-in. Okay, built-in is more like in the programming language, for example, you have something that known already, so you cannot name other things in the same name. Okay, so the name of the object is already identified by the system, such as the keyword in the programming language or the object-oriented systems, for example, or any things that fixed, you cannot change it or name other things in the same name. So we call this what? Built in. Now, now we always use what? We always use what? Name of the object to identify it. Okay, name of the object to identify it. It is very simple and easy, and it's the most used technique to identify the object in the programming. You probably use it without knowing that you are using it. Okay, now the operation. Okay, it could be a service, or it could be self, operation. So an operation denotes a service that a class offer to its client, or a client. This is the class represent the object, and there's some operation here. So if you ask a request, you ask for a service, either you are a user or you are another object. Okay, you ask for a service, so that means what? It's an operation. So the operation donate a service that the class offer to its client, no matter who are the client in the system or outside the system, human or another program or another object inside the system. The operation also has three things: selector and iterator. You know that because you have done some programming probably. Now modifier will change. Okay, will change something in the okay, will change something in the value. Such as, for example, we use in Java set and get function. Set is changing the value. Okay, and also selector. Okay, selector does not change anything. It just show the value, such as get. Okay, in Java, for example, right? Such as the function get. Give me the value. I don't want to change it. I just want to see what's the value. Okay. If I want to change the value, I use the modifier, which is set. Okay. Iterator. It's if you have an object like this, and you have things in the object, such as parts inside the object. Okay. Then you can access these parts, in order. Okay, in some defined order. So that means you access more than one object somehow in a loop or in an order way. Other kind of operation could be within we use for some time constructor and method. and the constructor. The constructor will initialize all the variables and create the object. The structure will remove all the values and destroy the object. So we use this in Java. When you start the program, each class should have a constructor and destructor to make the program run in a safe way. Any question about this? Okay, that's good. You all, mashallah, and you're a good programmer in Java. All right, for the rules and responsibility, okay, each one has actually something has to do, or he must do, or something. As a student, you have some responsibility, you have some rules to do. So basically, it's the same way in object-oriented. Okay, we have some rules, we have some responsibility. So the rules is basically just a mask, okay, that the object where to define or contract between an abstraction and its client. So it is more like, if you have an object here and you want to talk to the object, you cannot talk to the object directly. That means you talk to the abstract, which is the mask that the object use. Okay, so this mask, this rule, define basically what is the object is. Define the rule of the object. You want this, I can do it for you. This is my rule. If you want something else, I can do it. This is not my rule. Okay, it is kind of a mask. Okay, that the object, it's just an expression. Okay, for the rule. Responsibility. That means that what is the purpose of exact in the system? What is the main goal of this object in the system? Okay. Now, in other words, to make it easy for you, the state and behavior object define the rule. Very simple. Okay. Define the rule of the object. The state and the behavior of any object will define the rule of the object. Okay. That means that what kind of play that the object will play in the system. It's similar to the movie. Okay, what role you are playing? I'm the hero. I am the poor man. I am the a husband or the wife. It's just a rule. Okay, who defined this rule and behavior? Okay, now any object in the system has some role in the system to do. Okay, who defined this rule? By setting up the operation or the function inside the rule. The rule of this object is to do the calculation, okay? And the state of the object could be yellow or green or red. That's defined also the rule. It is just a state of an object, okay? Now, an object, okay, will fulfill the abstraction responsibility. If you have some rules, okay, you need to fill these rules by taking responsibility on these rules. So you are a student. Your role is student. What is your responsibility? To study, to pass the exams, to come to class, to attend the class on time, and so on. This is your responsibility as a student role. Okay? Teacher has a different role. Okay? His responsibility is to do something, teach, give exam, write exam, record exam, and so on. Okay, now the same object may have different rule in the same system. So if you define the rule of the object, it does not mean that this object will have only one rule. It could have, any object could has more than one rule at the same time. Okay, for example, you are a student, but at the same time you are family member in your family. Okay, you work somewhere, so you have different rules in this life. Consider the life. Okay, it could be, you could be a student and you could be working somewhere. So this is two rules. Okay, for the same person, for the same object. Okay. It could be, this. Now you could exchange dynamically between the roles. Okay, that's should be fine. You can play any role anytime in the system. Now the